Hello, everyone. Thanks for joining this instance of the Antrea community meeting. Today, we have two main topics on the agenda. First, Kumar is going to present some findings about Antrea scaling. He ran some tests and he wants to present the results of these tests. And then Chan wants to discuss three Antrea issues that have an impact on users. I think one of them is could be considered a bug, and the other two are more like feature requests. So Kumar, do you want to get started?
Yeah, sure. Is my screen visible?
So we can see your screen, but we cannot hear you.
Hello.
Yeah, I think you can go ahead, Kumar. I think I can hear you.
Oh, that's my bad. I didn't have sound.
Okay.
All right, thanks.
Yeah, thank you. So hello everyone. So my name is Kumar Atish, and I will deliver a short presentation on this topic, Antrea scale test, that is 10,000 VMs in agentless mode only. So we did a scale test in agentless mode only, and the result of the test will be shared in this short presentation. So we'll cover the data set which we used for the test, and I'll share the test setup details, how I performed the test, and the findings, the results which we got, that is how much time it was taken and how much CPU and memory usage. So the data set which we used is like, I took reference from the performance benchmark tests which are already there in the Antrea upstream repository. So based on the similar lines, I created a data set. That is, we had a one namespace. In that, we had 10,000 Antrea network policies and 10,000 external entity objects. So the relationship between external entity and the Antrea network policy is such that there is one Antrea network policy per external entity, with one ingress rule in each Antrea network policy to select an external entity from which the traffic will be allowed. So there are I created in such a way that there are 5,000 groups. In each group, there are two external entities and two Antrea network policy. Let's say external entity A and B, Antrea network policy A and B in one group. So Antrea network policy A is applied on external entity A to accept the incoming traffic from external entity B. Similarly, Antrea network policy B is applied on external entity B to accept the incoming traffic from external entity A. So this is in one group. So there are total 5,000 groups. So in total, we have 10,000 Antrea network policy and 10,000 external entity objects, and all are in the same namespace. So this is the data set which we used. Have I made it clear? If anyone has any questions on this data set. Okay, so I'll move to the next slide, which is this one. This is the example of the Antrea network policy and the external entity which I used. So this IP is just randomly generated for each external entity, and labels were used to select Antrea network policy, to select external entity for the Antrea network policies. So this is the example which I used. Then the test setup. So the objects which I showed in the previous slide, all the 10,000 ANPs and external entities namespace. So I wrote a Go program to and use the clients to create the objects, and then the objects were created on my local 3-node client cluster, which was used for the test. And the time was calculated from the Antrea controller log. So while applying the Antrea YAML, I increased the verbosity to 5, and then these objects were created. And when the objects were created, I monitor the logs. When all the objects were processed, all the Antrea network policies were processed. When you increase the verbosity of the logs, you can see that there is a timestamp when processing of network policy and applied to groups and address groups are all finished. So there is a timestamp. So when all this 10,000 ANPs and externalities were processed. Then I restarted the Antrea controller pod. And after restarting Antrea controller pod, the time which, again, I checked the logs, and the time which it took to calculate, to process all the created Antrea network policy was measured. That time was measured. So firstly, the Go program was run to create the objects, and logs were monitored so that all the network policies are processed, and then the controller pods was restarted. And after restarting again, whatever the time we got, that time is calculated. Moving on to the next point, the CPU and memory usage. For this, I wrote another Go program, and I use metrics package to get the CPU and memory usage of the Antrea controller pod. And this was measured at an interval of 10 seconds so that we could get the accurate result, most accurate result. And the maximum CPU and memory was updated at the interval of 10 seconds each. So this is the way I performed the test. And if anyone has any questions on this. Okay, so moving on to the next slide, which
Kumar,
is.
I do have a question. If the metrics were measured at an interval of 10 seconds,
Yeah.
could the calculation already been done before the next measurement? I suppose perhaps sometimes it shouldn't even take 10 seconds to finish the calculation. Is it correct?
No, means I read somewhere that this metrics package it does not calculate on its own. It queries kubelet, and it calculates at an interval of 10 seconds each. So while the object creation was this metrics at an interval of 10 seconds, by means a program was kept on running, and I was in another terminal, and I was measuring the monitoring the logs. So after every 10 seconds, whatever the CPU and memory usage which we're getting, we were updating our maximum memory and maximum CPU data. So it was.
How long it typically took to run a data set to finish testing a data set?
Yeah, it took around 45 seconds for the program, but around 33 minutes for the Go program for the from the Antrea controller logs, around 33 minutes for the first time when objects were created. After restarting, I'll show you the next slide. So the metrics were calculated after restart, I'm saying.
Okay.
So here is the result. So firstly, Go program was run to create the objects. That took around 40-45 seconds for the Go program. And I was monitoring the Antrea controller logs. It took around 33 minutes to finish processing all the network policies. Then I restarted the Antrea controller pod. And after restarting, it took around 17.5 seconds to finish processing all 10,000 ANPs. And during this 17.5 seconds, the maximum CPU usage went as high as 1038 millicore and memory as 277 megabytes. So during this 17.5 seconds interval, this the 10 seconds interval which I was talking, that program was running just before the start of the Antrea controller, just before restarting the Antrea controller pod, and it was kept running until this 17.5 seconds or so.
Got it. If I understand correctly, if the test lasts 17 seconds, you only got 2 or 3 metrics from the. Okay, perhaps. How about you? What would be the problem if you decrease the interval to be per second? Will that be a problem?
It will not be a problem, but I think the result won't change, because I read somewhere that metrics package which I used, that does not itself calculate. It just queries the data from the kubelet, and kubelet has kubelet itself calculates at an interval of 10 seconds. So
Okay.
we cannot decrease the kubelets interval. So that's the reason of keeping it to the as small interval as possible.
You mean kubelet provides an API
Yes.
to provide the metrics of a pod?
Yes.
Okay.
So
I wonder if we could just measure the program directly via some other mechanism, not via kubelet. It's giving it only provide the data every 10 seconds. Perhaps per second, a metrics will be more reliable to capture the top usage during this process.
Yeah, that's correct. That's correct. I also wanted that, but I didn't got that because so I use this is as close as possible I could went. Also tried the Kubernetes dashboard also provides the metrics, so that is in interval of 1 minute, and this metrics is as small as 10 seconds. So I researched, but I didn't got any for 1 second. I'll try again for that.
There should be some system tools that can be used to measure these metrics directly. If I know MP stat or something like that.
Okay, I'll look into it. Sure, thanks.
Sorry, Kumar. Actually, I have a question regarding the matrix package. Do you mean it's our internal matrix package or it's a third party tool?
It's open source package.
Okay. Oh, okay, got it. Thanks.
Yeah. And this is the result which I got, which I shared. And that's all from my side. If anyone has any other questions.
Just a quick question for context. So how does that relate to performance scale testing that we've done in the past? Was there a focus on external entities specifically?
Yes, that PR is open in the upstream. There also I used the same data set, this one only, but the time which I got there was 7 point some seconds, and the CPU and memory usage which I got there, but that was done using the fake Antrea controller. Like in you see, we have for unit tests we have the fake controller. So there we have fake controller. So using that, the test was done there. So it is the PR is open in the upstream. So we can take a look there.
But why did we use external entities specifically in this benchmark?
Yeah, because like you see the topic is 10,000 VMs. So the VMs are registered as external entity in the Antrea. So when you want to apply Antrea network policies on VMs, so you register the VM as external entity in the Antrea, and then you apply the Antrea network policy, and you select in the you apply it to, you select external entity selector, and then match labels. So the test was to check whether Antrea is network policies are able to applied on large scale number of VMs. And VMs are registered in Antrea as external entities. That's why.
Okay, so that was specifically in the context of like the NEFE project?
Yes.
Okay.
So, and that is why it is agentless, because we didn't use any Antrea agent. This IPs are also just random private IPs. Yeah. So if anyone, any other questions, then I can stop sharing. Thanks, everyone.
Thanks, Kumar. So if there are no other questions, I think, Chan, we can move on to you. And there were 3 GitHub issues you wanted to discuss.
Yes, thanks, Anthony. Can you see my screen? It should be my browser.
Yeah, okay. We can see all 3 tabs here.
Okay. Then I want to discuss 3 user-reported issues, and some of them are feature requests, and some of them are actually problems in Antrea. Let me start with the first one. It's supporting DSR for load balancer in Antrea, and I have prepared slides to introduce the background and potential design. Let me share my screen to the slides. And the motivation is that currently we implement Antrea proxy and proxy O in symmetric mode, that in which mode that the traffic will always flow in the same path, both for the request and the response. And traditional load balancer has a mode which is called DSR, direct cell return. It could basically it works in the way that the request will be load balanced by the load balancer to the back end, where some special mechanism, some implementation might just change the destination MAC to the backend servers, and doesn't change the IP address and the higher payload. And then the backend server could return to the client directly because it has the original source IP, the client IP, and it also knows the server IP the client was accessing. And some implementation might use tunnel or some other encapsulation mechanism, like they could just encapsulate the request in a tunnel, or they could do some DNet in the load balancer, but they could encapsulate the original server IP in the header of the encapsulation packet and forward it to the server. And then the server anyways knows the original server IP the client was accessing, so it could still respond to the client directly, either getting the server IP from the inner packet directly or from the encapsulation header. So the typical traffic flow, if running DSR mode, is like this. And the advantage of this mode is that, as we see from the picture, because there is one less jump in the data path, the response doesn't have to go through the load balancer. In theory, the latency should be smaller because of the reduced jump, and because the backend server could respond to client directly, the output bandwidth will no longer be limited by the bandwidth of the load balancer. It is typically useful for traffic which has a lightweight request but heavy response, because if we imagine about this, when there are 2 backend server and 1 load balancer, and if client request some payload from the service. The backend, the two backend server could talk to the client directly, bypassing the load balancer. So the total bandwidth will be the sum of the of each backend's bandwidth. And another benefit of this mode is that the server can see the client IP, can see the original client IP, because typically in this mode, the server needs to respond to client directly. So load balancer doesn't do masquerade for the client IP. And I think in Kubernetes, the typical usage of this mode could be the in-cluster load balancers. I think typically external load balancers doesn't need this because it might already perform DSR, because in kubectl implementation, it just assumes that the external load balancer has already will forward the ingress traffic to the node, and the destination IP will be the service load balancer IP. So typically, it might already work in the DSR mode by the external load balancer changing the destination MAC when it does the load balancing. And typically, the external load balancer should leverage the external traffic policy mode local to avoid another load balancing in cluster by asking the request only forwarded to the pods running on the node that receive the traffic. Based on the how the DSR mode works in typical load balancers, I found that in current Antrea's design, it should be not hard to implement DSR, as described in the picture. When the client wants to, assuming that we are using the Antrea service external IP feature to announce the external IP of a load balancer. Let's say it's the load balancer IP of a service is 2.2.2.2, and the client IP is 1.1.1.1. And let's say if we want to access a service whose backend is port 3, and the load balance IP is currently assigned to this node 1. And when the client sends the request, it will first reach the node 1, and in previous implementation, we will just DNAT the request and send it and tunnel the both DNAT and SNAT the request and send it to the backend port. So the backend port could respond to the request, but because the destination IP will be the gateway IP of this node, so it will be forwarded to this node and perform NDNAT and NSNAT, then respond to the client. With DSR mode, on this node, on the ingress node, we don't do we don't change the IP of the request, but we still select one backend endpoint. We could choose to change the backends to both node-based and port based, and we could aggregate the number of the ports on a node and improve the weight of a packet. Then if the packet is the packet that is node based, we will not do any IP translation, but we will just tunnel the request to the selected backend node like this. We keep the original IP in the as the inner packet of the overlay packet, and the outer header will be the two nodes IP, just like a regular tunnel traffic. And on the backend node, we will do another load balancing and selecting local ports only. And after we select one backend port, we will perform DNAT on this node and forward the packet, the request packet, to the selected backend port. And right now, the backend port receives the traffic with the original source IP and with destination IP set to itself. So it will respond to the client IP directly. And when the packets reach the response packet reaches the open switch, we will do DNAT, perform DNAT. So the packets will be the destination IP of the response will be changed to the original source IP and be forwarded to the client directly, like this way. Before it reaches the open switch, the response source IP will be the port IP, and the server IP will be the client IP. And after performing DNAT, the source will be translated to the service IP, and the server IP will still be the client IP, so the client can receive the response. And I have verified with some hack flows, and basically it works. But I also found some caveats. The first, and is very typical in with DSR mode. The first is the connections will be marked as invalid in countercheck on ingress node, because as we can see that the request, the ingress node open with switch will only see the request packets, so it will never reach establish for the connection. But it's okay for this node. And also note that in the host network namespace of the ingress and backend node, the connection will both be marked as invalid because they only see one packet of one direction. But that doesn't affect the function, because we in OpenSpace iptables rules we installed by Antrea, we didn't check the connection state when forwarding between these two devices. But there is a problem in the open switch of the ingress node. The problem is that open switch doesn't provide the CT mark and the CT label for invalid connections. It means that even when commit the connection on the ingress node, for the following packets, for the following request packets, we cannot get the connection state after the first request is committed. This will cause different selections when we load balance the following packets, because a packet we leverage connect track to remember which backend node or port we choose for the connection. Now we cannot leverage that. And after some investigation, and we found that run action was provided before Open vSwitch supports the connect track, and it could provide similar functions. I have tested some flows, and basically it works. That for example, this flow means that we will generate one learned flow every time we met a new connection, and it is source port based, which is different from the searching affinity we have implemented for services. And we need to set the fin idle timeout to a small value so that after the connection closes, the Open vSwitch could remove the learned flow quickly instead of waiting for the idle timeout. Otherwise, there will be massive of open flows, even if the connections are all closed gracefully. And I hacked the data path with this example flows. For example, I override the learn bands, the buckets of a group to actually, this doesn't really change anything. The most important change is that in endpoint DNAT flow, instead of performing DNAT, I changed it to not doing that, but in service in layer forwarding table, I will check the reg mark, which has set during the in the service LB and endpoint DNAT, and I forward the packets to another node via the tunnel and setting the tunnel IP to the backend node's IP. And another important flow is that we should stop dropping the invalid packets, but this could be done conditionally. For example, we only allow invalid connections towards a service IP. And with these flows, I can briefly make DSR work. And I also prepared a demo. Let me share my console. For example, I have set up a 3-node cluster, and I have one service, which is Lauren Balancer, and its external IP in this one. And currently, the ingress node is assigned to kind worker, but the backend port is on kind worker 2. So that's first. And also I have 2 nodes. I have entered the namespace of the 2 nodes. And the first one is kind worker, and the second one is kind worker 2. Yeah. So in traditional way, the packets will flow both the request and the response will flow through the ingress node and will not appear on the ingress node physical interface, because it will always be tunneled to the ingress node instead of responding to client directly. Let's take a try. And we can see that we can see request and response on the ingress node, and on the backend node, there's no package showing on the physical interface. And let me add some flows to make the DSR mode work. Now, let's access the service again. On the ingress node, we can only see the request packets. And on the backend node, in the physical interface, we will only see the response. So this is basically how DSR works. And I also performed the simple benchmark to measure the latency. Let's first check the latency when running in DSR mode. Let's perform it a few more times to get more accurate result. You can see that it's about 8,300 requests per second. And if I remove this flow to reward it to the conditional mode, let's try again. Let's first remember this number. As you can see, this is the data for DSR mode, and this is the data for traditional mode. We could perform it more times. Yeah, it is about. Let me check. I guess it's at least 10% better than the traditional way, right? 20% better, higher 20% higher throughput with the DSR mode. But there is also a problem if you have a look at the test command I used. I use -k to keep alive so that the connection will, all the requests will use the same connection. This is because if I don't use keep alive and every request use a new port, I found the performance became worse with DSR mode. I'm currently still investigating the reason behind it. I guess it might be related to 2 times. We need to commit a connection 2 times with DSR mode, but with or we need to do 2 rounds of load balancing with DSR mode. But with transition mode, only the ingress node will do load balancing. So I'm still investigating this, but I think the result of latency is actually promising, because it shows that with less jump, the client could receive the response faster, and the total bandwidth should be also benefit from this mode as well. And let's get back to the presentation. So I listed some to-dos regarding this feature. One is to measure the latency in various modes, as I mentioned. currently it works better with a single connection, but it works worse with new connections. If every request use a new port source port, and I also want to investigate how much benefit it could bring with to the throughput. And I have tested it with Antrea service external IP. It basically works, and I also plan to test it with other popular in-cluster load balancers like MetaB to see if there is any gap between the implementations. And because of the not ideal data with new connections, I want to see that whether we could improve the flow to make it always work better, regardless of the mode of the traffic. I guess it might be related to the 2 rounds of load balancing. So one potential issue, solution is that we encapsulate the backend information when tunneling the packets to the backend node to avoid another selection. Yeah, that's all from my side for this feature. Any questions?
Chan, I have a question.
Yeah, please.
When we implemented session affinity in Antrea proxy at the very beginning, there was an issue because OVS has a delay to install a flow after the learning action. And it was at most 500 milliseconds, and then we changed the config parameter in OVS to reduce it to 200 milliseconds. And so what that means is if, well, in the case of session affinity, if there was a new connection from the same pod within 200 milliseconds, there is no guarantee that it's going to go to the same backend for the service, because 200 milliseconds is how long it can take now in Antrea to install the flow after the learning action. And that's because it needs to go to the user space agents, and then the OVS user space agents need to update the data planes, right? So do you think using the learning action and knowing about that limitation, do you think that will be an issue here? Where packets maybe from the same flow could go through a different selection process?
Yes, that will be a problem. And thanks for reminding this. I suspect the current bad data with new connections might be related to this, because in the test flows, I have only one backend, so it will choose that anyway. But it may have to, the following packets might have to generate a long section, a long flow again. Right? If the first long flow is not persistent fast enough, and yeah, and I think that if the issue is still there, perhaps there will be issue when there are a number of backends in the flow. Yeah, we need to think about the solution.
Yeah, put the link in the chat. I think it's kind of like a design of OVS where learning was mostly used for MAC address learning. And so for that use case, having the delay is not an issue, because until you actually learn the flow in the data path, you can just like keep broadcasting the L2 traffic. But for our use case, it could be an issue.
Yeah. Then we either need to further investigate whether we could make city states available even with a single direction of traffic, or we need to check whether there is a workaround for this learned action, or perhaps we could use some consistent hash or some other mechanism to select the backend to guarantee that it will always be the same backend with the same with one file tuple metadata. I will keep that noted.
Yeah.
And
maybe consistent hashing with groups, yeah, could be a solution.
Yeah. Thanks for the suggestion and bring up the issue.
Hey Chad, like I have a question. Like, so normally, like it will improve the response time, right? Like from the server to the client directly, like bypassing the load balancer. But what about that, like firewall and other things which are also there alongside with the load balancer? So that will also get bypassed while responding to the client and server.
This DSR works in cluster, so whatever external firewall is there, it should still be the same, I guess. But if you mean the nail policy we have, I haven't thought about whether it will affect the nail policy. Perhaps it, if user have applied a narrow policy to the service directly, perhaps it has some impact because I'm not quite sure. I need to investigate the impact. Yeah. And that's a great question. Yeah.
Thanks.
So I have a question on the narrow policy too. For example, previously, if the source client IP will be SNAT, and then if we use ACMP to restrict which source IP can access from external network to a specific set of pods, it's not possible because the source IP will be changed. But this time, if actually it keeps the source IP, does that mean ACMP can be used in such case to block, for example, some source IPs from external to internal pod via service?
Yes, it's possible, and yeah, that's one benefit of this mode. But actually, we do have one kind of nail policies for the use case you mentioned. We support applying nail policies to service directly, and I remember it's we might currently we might limit the service type must be node pod or load balancer. I don't quite remember, but it can also block the traffic before it is denetted and snatted on the ingress node. Not sure if it already can work for you.
Yeah,
but
thanks.
yeah, that's true that with DSR mode, we can enforce narrow policies on port interface, and regardless of whether it comes from in cluster or the external network.
Understood. Thanks.
Hey, Chan, sorry, I had a super quick follow-up question about what we discussed before. So you said that for invalid connections, CT mark and CT label are not available in OVS, but can you remind me why we need CT mark and CT label on the left node here, ingress node?
Let me think about it. I remember we I for the following packets, because we don't perform NAT, right? So the source IP and the destination IP are the same when they are forwarded out of the ingress node. But we have to choose one backend node, right? And to remember the backend node, we have to persistent the node information somewhere. So
okay.
the per connection storage is the city mark and the city label. Yeah, that's why I need it.
Oh yeah, that makes so it's not for other features, it's just that for that feature, if we were using contract, we would need to have access to city label and city mark. Okay.
Yes, yes.
Thank you.
Or if we have other ways to get some persistent date for a connection, we could also work around this. But currently, it seems this is the only choice.
Yeah, thanks. If there are no other questions, we have about 10 minutes left. So I think, Chan, you can probably cover one more issue. I don't know if we're going to have time to cover both of them.
Okay, I will try my best. I think the following two, I don't have a real proposal, but just want to get some opinions from the community. The first one, I think some of you have heard that after enabling network policy logging, and if there are many connections will hit the policy, it will cause packet drops unexpectedly. I think that was not intention according to the discussion, but currently the issue exists, and we have to tell users to not enable network policy logging when it could be hit by many traffic. So I think that's not an idea, and I mark it as a critical urgent issue, so that we can prioritize the fix in 1.13. I'm not sure if we already conclude one solution or who is going on working on that. I see that there has been some discussion between Antony, Wiki, and Wenyi. So do we want to have some discussion here, or who will be tracking this issue?
Chen, maybe you can firstly assign it to me. Maybe I can spend some time on it.
Okay, thank you. Okay, if no more inputs on this issue, I can quickly go through the last one. This is an issue opened by one user this 9 months ago, and the requirement is to enforce their policies on node interface, like what we do in non-Kubernetes node with the external node feature. However, you know that because we don't have control on the traffic accessing the node or generated from the node, because we don't bridge the physical interface to OpenWSwitch. So currently this is not possible. But I wonder that given that we have implemented external node and we have a bridging mode in Antrea IPAM mode, whether it is possible that even we don't run Antrea IPAM, but if user could set the bridging, let me see, the enable bridging mode to true, we could just bridge the OpenWSwitch, the physical interface to OpenWSwitch bridge, and then it is possible that we could enforce their policies like the external node feature, and note that the regular traffic is still forwarded by the entry gateway interface, and will be netted by the host network when it is accessing the external network. It still works in layer 3 way, not L2, even the interface is breached. But we just have control on the traffic from and to the node physical interface. So I wonder whether this implementation makes sense to you, and whether it is worth to implement the future in some upcoming release, or we should deny such a request. Any opinions on this, Yang, Anthony, Jinjun?
I think earlier we think about using the TC to redirect traffic. Can that be a possible approach? Or actually, I forgot what we discovered with TC approach when we do Antrea proxy wall feature. That we found any major issues with TC, or so we gave up? Or?
When implementing the Antrea proxy feature, the real problem is that we didn't see any benefit by just forwarding, using routing to forwarding the traffic to Antrea gateway, and the performance is not better, but it's much complicated.
Yeah. I see. Yeah, I think moving the physical interface bridge, we talked about it before. I think the major concern I have that that means probably to manage the physical interface configuration. Maybe in some cases it's easy to support, but probably it's complex to support all the cases.
Yeah, I understand that, and I have one condition for this feature is that this will not work by default because we already have one configuration enable bridge mode. Yeah, I mean that only if user enable this flag, we will bridge the interface. That means for most users, they will not be affected, and only for users they do want to enforce net policies to node interfaces, they will need to set this proactively, and they might need to be aware of some caveats, like what you mentioned, that for some system we don't manage the life cycle of the interface, and they will need to handle some corner case like a restart or something like that.
Yeah, understood.
I just wonder whether we should keep tracking this, because users are asking when we could have this, or we don't want to support it at all.
Yeah, I think for the use case, it's a wild one in my mind. Because I don't know how we want to prioritize or any particular approach we want to take. But I do agree it can be a wild use case.
Okay, then at least we could still put this in backlog and see whether which release and whether there's a very good solution we could choose to implement.
Yeah.
As far as I know, the calico nail policy, could work, but it's very easy for them because they just
Yeah.
program iptables.
Even with eBPF, it's pretty simple to implement.
Yeah. Okay. I think time is up, and I have no more topics.
All right, thanks, Chen, for the comprehensive walkthrough. We're out of time, so if this is everything and no more questions, I'd like to thank everyone for joining, and we'll see everyone in 2 weeks.
Thank you. Bye.
Thanks. Bye.